among the handful countries along with Russia to have its own supersonic missile. All these and many more visionary research by the DRDO getting translated into world-class products for the Indian Defence Services. Tejas, India's light combat aircraft, is the smallest and lightest multi-role supersonic fighter aircraft of its class. Tejas is the pride of the country and a step towards Make in India initiative. Airborne Early Warning and Control System, AEW&C. An eye in the sky is a potent force multiplier, providing surveillance, tracking, identification and classification of the airborne sea surface targets. Rustam 2, the multi-mission medium-altitude, long-endurance UAV, carry out the intelligence, surveillance and reconnaissance ISR roles for the armed forces. The aerostat system Nakshatra has proved to be an excellent platform for surveillance and communication for a variety of civil and military applications. Netra is a man-portable lightweight aerial vehicle used for surveillance and reconnaissance operations, aerial radiological surveillance of nuclear contaminated areas. IR flares developed for different military applications like tracking path of missile, training the air crew and decoying the attacking heat-seeking missile. Astra, the beyond visual range air-to-air missile, can intercept aerial targets at a long range. Akash is the medium-range surface-to-air missile system with the capability to engage a wide variety of aerial threats up to a maximum range of 25 kilometers and up to an altitude of 20 kilometers. LRSAM, to galvanize the air defense capabilities of the country. DRDO collaborated with Israel to develop the long-range surface-to-air missile LRSAM for the Indian Navy and medium-range surface-to-air missile MRSAM for the Indian Air Force. BrahMos, a collaborative effort between India and Russia, is the only supersonic cruise missile in the world today with flight range of 290 kilometers. Pinaka Mark II, the multi-barrel rocket system, is equipped with navigation, guidance and control kit and transformed to a guided weapon with a range of 75 kilometers. ATAGS, with advanced features in terms of high mobility, quick deployability, automatic command and control system with night firing capability in direct fire mode. WAP is a multi-utility wheeled armored platform with modular design, configurable for variety of combat and combat support roles. DRDO developed latest radars. Ashlesha, Swati, Arudra have proved their mettle for a wide variety of applications. DRDO developed sonars, have been the mainstay of Indian naval ships and submarines. Marich, the advanced torpedo defense system, employs both expandable and towed decoy against incoming torpedoes. Varunastra, the heavyweight anti-submarine torpedo, is capable of targeting quiet and stealthy submarines in intense.
Greetings and warm welcome the panelists and attendees here for this webinar from viewers from India as well as viewers from rest of the world. We thank you for taking your time and attending today's webinar. We have an interesting webinar today from Sri G. Satish Reddy, Secretary, Department of Defense R&D, and also Chairperson of DRDO. So before going into the webinar session, I would like to explain you some of the housekeeping rules. This webinar is being conducted on behalf of Department of Defense Production, Ministry of Defense, Government of India. And the participants can raise your questions in a Q&A section. On the down ribbon on your screen, you are able to see Q&A. There is a tab is there. You can click and you can post your questions. Only the questions which are asked in the Q&A will be addressed by the speaker. In addition, if you have any technical queries and technical issues, you will actually able to chat with the technical team which is overseeing this webinar please type your requirements in the chat. It's an informal way. So now also you can just chat, say, how is the audio and video quality? If it is okay, just chat okay, good, very good, like this. I'm requesting the attendees too, so that we know that video and audio reception is very good to you. So there's a chat option is there. I hope I am able to. Thank you very much. A lot of people are giving 10 out of 10 for the video and audio quality for today's webinar. We have an exciting session, and in this webinar, we are organizing this webinar on behalf of the ministry, as I already told you. This with the tool Digital India LMS, developed by National E-Governance Division under Digital India Program, Ministry of Electronics and IT. And with me, I have my colleagues, Ms. Bhumika is there, and Firoz and Vimal. They are also going to assist us for this webinar conduction. Thank you very much for joining one more time. Now, I will request the senior most representative of ministry to introduce the speaker officially from the ministry point of view. We have with us Shri A.D. Rane. He is a scientist G and also Director International Cooperation, DRDO headquarters. He will be formally introducing our speaker today. So over to you, sir. Please, I request you to introduce the speaker to the attendees.
Good afternoon, everyone. My warm greetings to Dr. Reddy, all participants and the team NEGD. We are aware that today's webinar is the fifth in the series towards the kickoff of Aero India 2019, which is being held at Bangalore from 20th to 24th February 2019. The speaker for the session today is Dr. G. Satish Reddy, Secretary to the Government of India, Department of Defense R&D, and Chairman DRDO. Dr. Reddy is also the Director General of Aeronautical Development Agency. He is well known for his decades of significant contributions towards indigenous design, development, deployment of diversified missiles and strategic systems, guided weapons, avionics technologies, and for sustained efforts in advancement of aerospace technologies and industries in India. Dr. Satish significantly contributed to the formulation of many R&D policies related to missile systems, aerospace technologies, and conceptualized modalities for promoting innovating manufacturing in India. Earlier, as Director General of Missiles and Strategic Systems, he spearheaded the Dr. APJ Abdul Kalam Missile Complex, a national R&D facility and technology center of missiles in India. He steered the design and development of a wide variety of tactical and strategic missiles and guided weapon systems. As a distinguished scientist and director of the research center Imarat, he led the design and development of mission-critical advanced avionics systems. Dr. Reddy has bolstered self-reliance in critical technologies, promoted Indian industries, strengthened academia collaborations for indigenous development of wide range of avionics systems and subsystems, which would have otherwise costed India several thousands of crores in imports. He has fostered a conducive ecosystem to strengthen manufacturing and research base in the country so that industries can become an integral part of the national defense programs, and strengthened more than 300 industries with aerospace standard production capabilities. He holds the distinction of being elected as a fellow of the Royal Institute of Navigation, London, the Royal Aeronautical Society, UK, and a foreign member of the Academy of Navigation and Motion Control, Russia. He is an honorary fellow of Computer Society of India, as well as the Project Management Association of India, a fellow of the Indian National Academy of Engineering, IET UK, an associate fellow of American Institute of Aeronautics and Astronautics, and many other academies, scientific bodies in the country and the world. For his distinguished contributions, Dr. Satish has received several prestigious international and national awards, which includes the Silver Medal of the Royal Aeronautical Society, London, the Homi J. Baba Memorial Gold Medal, the National Aeronautical Prize, the National Design Award, the National Systems Gold Medal, the first IEI-IEEE Joint Award for Engineering Excellence. He's also a recipient of the Dr. Biren Roy Space Science Design Award. and the Astronautical Society of the India Rocketry and Related Technologies Award. He has been conferred with honorary degrees of Doctor of Science by many leading universities of India. Dr. Reddy would be sharing his thoughts on the future battlefield technologies, keeping the Indian warfare landscape and combat innovations as a pivot. All kinds of autonomous systems shown in the movie Terminator, that is the robotic soldier, the self-thinking and self-learning machines, adaptive materials, smart firepower, intelligent platforms, they were not certainties when I was a young boy. At present, the battlefield is everywhere, in the vicinity of our workspace, to the distant border areas of our countries. There's a constant need of updating and upgrading technology to make the peace-loving people safe from destructive technologies and asymmetric battlefields. DRDO is trying to bridge the technological gaps for the Indian armed forces in this whole paradigm of warfare, to convert an idea into a useful combat technology. Let's listen to the views of Dr. Reddy now.
Thank you, Mr. Rane. Very good afternoon to all of you. Welcome to Aero India 2019 webinar. I also welcome you, all of you, either directly visit or indirectly you can visit the Aero India 2019, which will be held from 20th of February. In fact, DRDO will be having a lot of its products showcased there during the Aero India show. And many industries which are working with DRDO and DRDO technologies-based systems will be displayed by them in the Aero show there in Bangalore. So I request you to have a look at all of those technologies and see how further we can develop many more technologies for the defense applications. DRDO as a defense research and development organization working on various defense technologies has about 52 laboratories spread across the whole country of India, working on varieties of technologies, right from material technologies to naval technologies, to torpedoes, to missiles, to radars, to electronic warfare, to radars, then sensors, then telecommunications, and submarines, aircrafts, and many other technologies what are required for the defense applications, leaving aside the physiological parameters and other aspects of the soldier and soldier clothing, soldier small arms, ammunition, and many other things what are required for. So these are all the various technologies which DRDO has been working and trying to work for the futuristic technologies and systems. I have here with me my colleagues, Mr. Atul Rane, who has introduced me to you all. And we have Mr. Rituraj, he's from our laboratory, Artificial Intelligence and Robotic Laboratory in Bangalore. And we also have Mr. Amit, he's from Air Defense, part of Research Center Imarat, Hyderabad. They also join here with me in this webinar where we are communicating with you. Today's topic, what I have taken up is the future battlefield technologies. When we say future battlefield technologies, first, the battle future or even today, it can be between two states, or it can be between a state and a non-state entity. Meaning, the war is spread across whether the borders, or the sea, or the air, or it can be part of urban and built-up areas. The war can be more of asymmetric warfare, the way the situation is happening entire world when you look at it. And so identification of an enemy is a challenge. This is one of the important things. The war battlefield, which was only land, air, and sea, has got now the fourth dimension, the space-based technology, space-based systems. Space has become the fourth dimension of warfare. And the cyber technology, the cyber space has become the fifth dimension of the warfare. So these two also play a very important role in the battlefield, whether it is between the two states or between state and a non-state entity also. Today, even non-state entities also have access to the technologies and are able to utilize many technologies. So whether it is you're having a war with a state or a non-state entity, you need to have the state-of-art technologies. In fact, when you look at defense technologies have been driving the technological growth and innovations a lot. Whether you look at the satellite-based navigation technologies or even the internet technologies have actually originated from the battlefield or defense technologies. So defense technologies have been in the forefront, innovating future systems, future technologies, and futuristic systems and state-of-the-art systems. So when you look at the futuristic battlefield, it is heavily technology-driven. In fact, as I said, the battlefield always has been, to that date, it has been technology-driven. And always, war technologies have always asked for newer technology every time. So the technologies always have been more and more driven by the defense forces. And the present day and futuristic warfare, when you look at it, it is heavily information intensive. This is another important aspect. Today, the information flow is enormous from varieties of sensors spread across land, air, or space, or water, underwater. The information collected from the various sensors need to be in real time analyzed, processed, and to be disseminated. This is a very important thing. Need to have visualization of the battlefield in real time, and you need to have the update of the scenario of the battlefield online or in real time. This is one of the very, very important things when we look at the futuristic battlefield. Another thing, when you talk about the battlefield tomorrow, the collateral damage should be very minimal. That's one of the important parameters. That means you need to be very precise, very accurate is an important parameter. So when you look at it, the systems which were there as manned systems earlier are becoming unmanned systems and autonomous systems with artificial intelligence, deep learning technologies. This is one of the important change what is happening in the battlefield today. Today, the unmanned systems are able to autonomously define their own roles and decide the battlefield parameters, and even are able to launch weapons from those autonomous vehicles. This is one of the important development which is taking place. In the future will be mostly by autonomous vehicles, whether it is air or ground or underwater. And another thing is, the systems which were isolated earlier are standalone systems have become network centric, and they have become large area network centric. In fact, everything is connected to a net, including a soldier. That's how the system is going to work. And in fact, the futuristic thing will be few foot soldiers in the actual war, and mostly will be remote controlling many of the unmanned vehicles and systems and weapons. Similarly, the search and shoot capabilities have become sense and shoot, and also detect at longer ranges, track, classify, identify, and shoot. These are the technologies are emerging today. You are able to detect systems when a long-range missile, you are able to detect right at the boost phase itself through varieties of sensors, whether it is from spaceborne or airborne systems, and you are able to attack the system right in the early stages of it, much beyond your border areas. This is one of the technologies. Accuracy. Accuracies have changed from few meters or few hundred meters to meters to centimeters today. The systems are changing from meters to centimeters. This is one of the parameters which is very important for minimal collateral damage. The probabilistic kill has to become the assured kill. Again, the technologies ensure that the kill is assured, as I said, with accuracy and with lethality, what we are going to have, and reliability of the systems. The area weapons have become targeted weapons. And as I said, the targeted weapons are becoming even weapons of kinetic kill with centimeters and millimeters accuracies. And the tactical systems are becoming completely network-centric systems. The heavy and voluminous systems are getting highly miniaturized. They become portable, and you need less energy to make the system travel longer distances, longer ranges. The weight of the system and the volume of the system becoming highly minimal. This is another important aspect of it. With the few technologies which I'll be talking about little later, the change in the scenario of the battlefield is happening like this. Now, coming to the systems, let's say talk about whether aircraft or missiles, the range of the systems is becoming longer and longer day by day. And we are looking for systems which can travel very long, which can have standoff range of very long range, and you are able to attack the targets at longer ranges with higher degree of precision, as I said, about centimeters. This is one of the important things. Then the speed of the vehicle and the stealth parameters of the vehicle is another important parameter. The speed at which the vehicles are traveling are very high, and you are not able to give any reaction time to the enemy. And the stealth parameters of the vehicles, whether it is for the missiles or UAVs or aircrafts, is so minimal that you are not able to detect those vehicles. This is one important thing. The information sharing is horizontal and vertical, and insulate yourself and disrupt overhead adversaries' electromagnetic spectrum. This is another important thing. The spectrum, right from very low frequency to up to 40 gigahertz and even up to 100 gigahertz, is now the systems are available, whether the electronic warfare systems, the jamming systems, and electronic intelligence systems will be playing a very important role in the futuristic battlefield across the complete spectrum of electromagnetism. Another important aspect is, as I was mentioning earlier, the information superiority. Information superiority is the most important thing in the futuristic battlefield. In fact, as I said, when the war starts, much before that, the complete footprint, the information image should be available in the country. Whether it is space-based intelligence, whether you are able to launch satellites and get the complete information, or other mechanisms by which you are able to get the complete fleet movement, the location of the radars, location of the sensors, systems movement, troops movement, everything is very clearly available. The images are available, the coordinates are available. Is one thing actually is very essential before a war starts. That's how I said the space has become very important. It has become the fourth dimension of warfare. The air and missile defense and missiles technologies is one technology which is growing day by day. When you look at it, the missiles of ICBM range or missiles of air defense at a very long range of 400 kilometers, 500 kilometers are emerging today in a big way. And the vehicles size is reducing and able to deliver the payloads at a longer ranges at a faster speed. And the technology which is emerging here, many countries, many advanced nations which are pursuing are the hypersonic technologies, hypersonic missiles and related technologies what are required for those scramjet and related technologies for hypersonics. Hypersonic missile or the hypersonic glide vehicle, maneuvering glide vehicle is an important technology in the missiles area which will be playing a major role. Particularly the low-flying hypersonic vehicle at a very high speed of probably about 15 Mach to 20 Mach will play a major role in the future technologies. The radars are emerging to be across the spectrum radars up to Ka-band. In fact, the seeker systems also across the spectrum, whether it is X-band or Ku-band or Ka-band seekers, which give you sufficient range for the missile systems, which are again emerging. In these two technologies, particularly the TR module technology is highly miniaturized. TR module technologies with AESA radar is an important technology which is emerging with day by day changing the power of the TR modules in whether it is gallium nitride technologies or MEMS-based technologies, which is emerging in the TR modules and radars being built. And radars particularly, with the OTH radar, are very long range radars, having very high accuracy of attitude, are one of the emerging technologies in the battlefield. Need to have today radars which can detect an object with a very low RCS at a very long range and trying to give very precise coordinates of the system also with a high degree of angular accuracy. This is another important technology which is emerging, leaving aside the radars which are very small, portable, which can be used in the battlefield for varieties of applications of air defense to mine detection and related areas. And the airborne systems, whether it is the aircrafts, particularly the stealth aircrafts, having minimal RCS, are the weapons hidden within the aircraft, able to defeat the enemy's sensors, or have unmanned combat air vehicles which can deliver any weapons at a longer range, and the UAVs with varieties of technologies up to hail technologies, having weapons and delivering the weapons in autonomous mode. This is one of the important things. They was talking about highly miniaturized weapons are one of the important area here, wherein imagine a UAV having complete range of missiles at a highly miniaturized. You are able to go in an autonomous mode, identify the target, and deliver the missile which hits it with high degree of accuracy. These are the systems which are actually coming up in the futuristic battlefield. Similarly, autonomous vehicles in the land, autonomous combat vehicles, higher protection, higher maneuverability, network targeting systems, increased range with lethal weapons is another area of importance, which people are working in a big way. Soldier effectiveness, there is one important thing. Leaving aside the effective training what is being given to him. Low-weight protective gaze, multiple sensors, battlefield visualization, sensors, miniaturized and low-weight volume, lethal, accurate, and higher power personal weapons is one of the important things. The soldier is treated today as a soldier as a system. Soldier has the complete range of communication and is able to visualize the battlefield with the complete information what is available through various sensors which are able to give. And all these are given to him in a very lightweight technologies, which some of the technologies which are required by the soldier I will be talking about them little later. In fact, the commercial technologies getting converted into defense is one of the important aspects which future battlefield is going to have. We cannot have the futuristic battlefield with very costly weapons and costly systems going to be there. The commercial technologies which are available today, which can be converted into, which can be used in the defense technologies at a low cost, is one of the important parameters which is going to play a major role. And underwater reconnaissance vehicle, underwater autonomous vehicles is another important area which will be playing a major role. Already the autonomous underwater vehicles are trying to play a role, and in the futuristic battlefield, they will be playing a very important role. Submarines. Submarines with minimum sonar signature, minimum stealth signature, and capability to stay underwater for long durations like 14 days, 15 days, and 20 days is the technology which is emerging. With technologies like air-independent propulsion, a submarine doesn't have to surface to update itself for 14 to 15 days, and you can stay underwater. With the underwater imaging technologies, even this duration can be much longer with still having a very high accuracy of its own position is another technology which is emerging for having a precise positioning of the precise navigation of the submarine technologies. Today, as we are seeing, the artificial intelligence and deep learning are emerging in a big way. Artificial intelligence is going to play a major role in most of the weapons, whether it is autonomous vehicles or talk about any systems which have sensors which are able to detect the target under varieties of environments, weather conditions, and whatnot. And artificial intelligence in those systems play a role in identifying, defining its own mechanisms, guidance, and whatnot, and is able to defeat all the conditions and play according to the environmental conditions, and you are able to tackle the target. And this is one of the important areas in the weapons. The artificial intelligence is going to play an important role. Data analysis for target identification, classification, and intelligent decision-making is an important area. Capability to handle and process very large volume of data is another important parameter, to have very high processing capability at your end and trying to process them and disseminate the information and take the necessary decisions based on the analysis of these systems. Here, the futuristic technologies like quantum technologies play a major role. To have a complete secured information, need to have a quantum communication technologies play a role in the futuristic battlefield. The quantum gravity sensors, quantum navigation, quantum computing, quantum radars, they're all important major players in the coming futuristic battlefield. Any country, most of the countries are working on these technologies today to play a major role in the futuristic battlefield. When I talked about many of those areas like hypersonic technologies and lightweight systems and all that, materials play a very important role. And for any country, the fundamental aspect of technology development is the materials. Need to work a lot of materials which are lightweight, which are having high strength, capability to withstand very high temperature is one of the important aspects, particularly when I talked about the technologies like hypersonic technologies. Hypersonic technologies need materials which can withstand very high temperatures and very high loads. And materials which have high transmissibility of any electromagnetic signature, or particularly in the IR signature, a minimum loss in the radomes is another important technology, wherein the material technology plays a role to have today the antennas on the skin of the vehicle and smart structures. These are very important and will be playing a very important role. And so the smart materials, self-healing materials, and shaped memory alloys, the ceramics, the composites, they play a very important role. When I talk about materials, once the materials are there with varieties of alloys and composites and whatnot, the manufacturing technology is a very important thing, which you need to manufacture these systems with the latest technology and using the futuristic processes. Whether it is additive manufacturing technology, what we are seeing today, to foldable electronics, to foldable displays, to the textile manufacturing technologies for a very lightweight bullet proof jacket or bullet resistant jackets, to have a very low weighing bulletproof jacket today. The textile technology and the ceramics and materials technology is a very important technology, wherein the soldier can have a minimal weight, but still your bullet resistant jacket you are wearing. So the manufacturing technologies of these play a very important role. When I said soldier as a system, these foldable electronics, foldable displays play a very important role for a soldier to work as a soldier as a system. And when I talk about it, let me continue to the soldier as a system to robotic soldier. The future technologies will have a robotic soldier complete with artificial intelligence, deep learning technologies, having the complete technologies built in, or at least the soldier will be completely as I said, soldier as a system with all these technologies on the body of him, with including the automatic self-medication, sensing the injuries and then medicating him, providing automatic medicines to him, and able to communicate automatic communications or manual communications, and then having exoskeleton to make him more effective during the war. These are some of the technologies which are there, going to be in the future technologies for soldier and also a robotic soldier. In the asymmetric warfare technologies is another important thing, wherein highly miniaturized sensors, cognitive sensors, cognitive technologies, and many related technologies play a very important role. The sensors are very, very important for any battlefield. Whether you talk about IR sensor, or multi-band sensors, or talking about electromagnetic sensors, or navigation sensors, and which in the MEMS or in the NEMS area, most importantly, will be playing a most important role in the futuristic warfare. Countries which are able to produce highly miniaturized, low-cost sensors and which will be able to provide a lot of information will have an edge over its adversaries. And the propulsion technologies, particularly, the engines play a major role. The one which is going to give higher impulse with minimal weight is going to be the one which is going to play a major role. So working on the propulsion technology, which high energy materials, working on the engines, which are required for the future is one important area which play a major role in having a weapon with lower mass and higher range. This is another important aspect. The green insensitive and energetics is another important area which will play in the future. The directed energies, whether it is higher and high power lasers or electromagnetic weapons, they have an important role in the future warfare. Hyperspectral sensor, and as I said, in the space, you have launch on demand capability to deliver varieties of payloads which are required in the space, whether they are synthetic aperture radar payloads or hyperspectral payloads, or to have ELINT payloads or COMET payloads or signal intelligence payloads, and higher resolution images is one of the important areas in space technologies which will be playing a major role in the futuristic systems. And the power supply systems is another important area. Actually, we have seen a lot of development in the last 10 years in the power supplies and the batteries technologies, having minimal size, minimum weight, and able to deliver maximum power is one of the important areas in this, whether it's supercapacitor or high density thermal batteries, or talk about magnesium ion, sodium ion, and related batteries, what are required. And another area of imaging is the terahertz technologies. You are able to see through, particularly it plays an important role in the asymmetric warfare. You are able to see through the green fields in the forest, or you are able to see through the walls in the house. These are one of the important things. So working on terahertz technologies and simultaneously on the photonics is an important area. The photonics futuristic interconnects and photonics varieties of sensors is an important area. And today, the systems have moved from whether it is CQI to C4I to C5I or C6I today, and furthermore going to expand in the future. So this is another important area which is going to play a major role in the network-centric information warfare. When I talk about information warfare, the cyber technologies, cyber space plays a major role. You are able to protect your systems in the cyber warfare. You are able to develop varieties of products which can protect your systems is very essential. As I said, cyber warfare is the fifth dimension of warfare. As I said, when we talk about C6I, command, control, computer, communication, cyber, and combat systems, intelligence, surveillance, and reconnaissance are the important areas wherein you need to have a cyber protection and cyber systems, which you need to develop, cyber physical systems need to develop for the futuristic warfare. Having talked about some of those futuristic technologies for the future battlefield, today, the technologies emerge out of the academia. The basic research happens in the academia. So you need to work a lot in the academic institutes for the technologies, what I've mentioned, and what some of those technologies which I have not mentioned, which will be emerging also. So DRDO has been working with many of the academic institutes in the country and established centers of excellence in various academic institutes, whether it is IIT Delhi or IIT Mumbai or IIT Chennai or Jagadpur University and other institutes, established for varieties of technologies, whether propulsion technology or photonics technology or high power laser technology or artificial intelligence and robotics. And even talking about textile technologies related things also, the centers have been established to working on the futuristic technologies. And also you need to have, for the future battlefield, innovative systems and innovative products emerging out of innovative technologies based on this basic research and basic sciences what you have, basic technologies what have been developed. So we have been supporting the innovations and startups in a big way, particularly DRDO. There are many other organizations in the Ministry of Defense and also outside the Ministry of Defense which have been supporting these startups and innovations in a big way. Particularly, we have a technology development fund wherein somebody comes out with a technological prototype. We will be funding them to establish, to produce those products in numbers and get it qualified, get it accepted by the user and produce in large numbers. This is one of the schemes what we have established to support the industry. To support the youngsters and innovators and startups, we have also recently launched a program which will be continuous in the future. As our missile man of the country, Dr. APJ Abdul Kalam used to say, dream, dream, dream. We have introduced a scheme called Dare to Dream. Somebody comes out with an innovative idea, then we will be screening all those ideas what have come in varieties of verticals, areas which have been defined, which they are available in the DRDO website, screen them, and selected ones will be rewarded. And also, if that is worth immediately to getting into use, to establish an industry and produce them, we'll be supporting them in a big way to establish that industry and produce them also. Likewise, many other schemes, DRDO technologies are made available to the entire industry, and the industry should be able to produce them. The industry should come up also with research in niche areas. If academic institutes are working the basic research to applied research, the R&D organization should be working from applied research to translational research, developing prototypes. Industry producing these systems with sustained quality, and also developing systems with research in the niche areas is a very important thing. If the startups have come in a big way in the ICT area, startups should also be able to innovate in a big way in the defense technologies, which will be applicable for the future battlefield. So I wish the academia, R&D organizations, and the industry will have a synergy and play their independent roles and come out with technologies for the futuristic battlefield. And I wish all of you will be able to visit directly or indirectly the Aero India 2019, see the technologies which have been developed, take on from there, and will be able to develop futuristic technologies for the future battlefield. Thank you. Thank you very much.
Thank you very much, sir. At this time, there are a lot of questions have been raised, around 30 questions from the participants. Would you like to take some questions, sir?
Questions? Yeah, please.
Yes. I request the team to put up the questions on the screen so that the speakers can be able to take some questions.
I have answered the first question, how DRDO is planning to work with startups in terms of R&D. We have many problems which we have defined, and we are there in the website, and which we are sharing with the industries also. And the industries can take up that problem and they can carry out research in that particular area. If they come out, as I said, with an idea, we will be supporting with them to do the research and also to establish the industry. As I said, many of the academic institutes where we have established the centers of excellence, if they are students, they'll be able to take the projects to them. Or if it is a startup in the academic institute, through the academic institute they can have it. Or the startup directly can avail the facility of our technology development fund also. These are the various mechanisms through which the startups can work on R&D. and also develop the systems and produce in them.
Pawan is asking about whether, since DRDO has achieved self-sufficiency in missile technology, how do we plan to do the same for other areas of defense technologies?
Today, DRDO, not only in the missiles, in many other areas, it has attained the self-reliance. We are self-sufficient in radars, we are self-sufficient in sonars, we are self-sufficient in EW systems, we are self-sufficient in torpedo technologies, and many other areas. In the areas where we are to develop the state-of-the-art systems, we have worked out the roadmap for that, working with academia and involving the industries and trying to develop systems as fast as possible and very efficient.
Vipin has asked a very interesting question, which is of controversy all over the world. There's a lot of talk about it. How will you describe the imaginary line drawn between manned and unmanned systems in the future battlefield? How much control would be with the unmanned or manned system? I think we've got a wonderful guy here on Network Centric, and would you like to try it out, or shall I start off right now? Okay. We all know Steve Jobs, Elon Musk are against the whole idea of unmanned and autonomous weaponry. But we have to work on autonomous weaponry in the sense of at least, in fact, there are already weapons around in the world where autonomously the weapon can identify the target, but request for clarification and authorization of fire from a human person. This is the link which we hope, and we in DRDO are working only on those sort of systems.
Yes, I agree that the autonomy right now would be more focused towards surveillance and not 100% autonomy with respect to weapon engagement.
Yeah, another question which I think our chairman is going to feel suddenly. How is DRDO planning to counter hypersonic missiles technology? Is there any BMD to be put in place?
Presently, the technologies which DRDO is working on are ballistic missiles. It depends on the requirement what you have. And so the DRDO has been working on ballistic missile defense technologies. And in future, we'll be working on hypersonics defense technologies also after we complete this activity and then when the need arises.
I do see another interesting question, which is
the mid-future battlefield technologies. What are the expected transformations in DRDO? It's a good question. In the today's when the technologies are transforming a lot, and we also need to transform ourselves in a big way to cope up with these technologies. Need to work with industries in a big way and academia in a big way, engaging the industries particularly in a big way, making them our development partners is the most important area. Industry becomes development come production partner, and DRDO concentrates more on the research part of it to come out with the futuristic technologies more and more, working with academia, taking the lead from the basic research what they do, and try to work and try to make the systems based on those new technologies. And whereas the most of the development work and then related production work, you are offloading to the industry and making the industry work on the niche areas, themselves trying to develop many systems from there. This is the modus operandi where you will be able to work together, academia, industry, and DRDO, and will be able to develop the future battlefield technologies, concentrating more on the research.
Krishnamurthy, of course, obviously either a professor or a student, is asking, can a team of engineering college students participate?
Definitely, engineering college students can participate in many ways. Through the centers of excellence, what we have established in various academic institutes, the students along with the professor can participate and take a problem and work on that. Or we have, I forgot to mention earlier, we have a scheme called ERIPR. In the ERIPR scheme, you will be able to take projects, various academic institutes can take projects futuristic research and development projects, and which you can work on. Also, the students can participate who are above 18 years old age in the Dare to Dream scheme and show their skills and capabilities, and will be able to support those students through that scheme also. So there are many schemes which are existing to support even the students and academic institutes also.
We have a question. Has DRDO developed its own BMS, that is a battlefield management system yet? Care?
Yeah, DRDO has the capability to develop a battlefield management system, and those technologies have been realized into systems for both land and naval forces, and they're in different stages of deployment.
We are skipping the question on private industries because I think we've done that quite a bit. I think what we are going to do is we are going to take up only another couple of questions. Of course, I've suddenly lost the page. It doesn't matter. There's actually no questions here now, right now. Okay.
What is the role of DRDO in improving skills of companies required? That is the Bharati.
Yeah.
That question is important. I think it's a looking interesting question. What is the role of DRDO in improving the skills of the companies required for design, development, manufacturing of the
Smart sensor.
Smart. It's a very good question actually. Need to work with the industry in a big way in these areas. It is just not the industry. It is the academia and the industry both have to play a role in developing the smart sensors. As I said, we have given a couple of projects already to various academic institutes in development of the smart sensors with various academic institutes in the country. And we are encouraging the industries to join with the academia and take the technologies and start developing the product and producing them, taking the help of DRDO scientists also. As I said, academia, industry, and DRDO need to work together in this area, particularly smart sensors is an important area, which we have identified and which we are going to establish some more centers for these smart sensors. How can I join DRDO for
robotics
research and development? Rudraj, like to answer that question? You can always join Working Gate. In fact, let me tell you, we have in Jadavpur University, we established a Center of Excellence for Robotics and Artificial Intelligence. And you can join there and work with them, or take a project there and work with Jadavpur University, and we'll be able to support you through them direct. We'll be able to support you. Or if you're part of an academic institute, you can take a project directly from us and work on that.
Cryptic VK has asked what type of ammunition will be available in the future battlefield, and is DRDO working in this field?
DRDO is working on ammunition area for the varieties of applications, whether it is right from small arms to tanks and related guns and all that. And couple of laboratories working with some of the academic institutes or high energy materials related area, and they're trying to develop the ammunition for these weapons and also for the futuristic weapons.
Vipin, your question on whether an individual doesn't come up to the top 3 in Dare to Dream, and whether DRDO would help that individual, I think you get out of the... Yeah.
Definitely. It is not that the people who win in the first 3, others also will be able to definitely come up, and we will be able to support them. All the good ideas will be screened and filtered, and wherever it is worth taking it further, we'll be able to support them. Somebody was asking about the website was not working. I think yesterday there was a problem in translating from one server to another server. For some time it was down. I think the problem is rectified, if I'm right, and it will be available.
Okay, we'll field the last question now because I think we are running out of time. There are a lot of questions which are...
Very important last question. Yeah. How do you like to address quality process and reliability design? This is a very important question. Actually, what you have asked is, as I was talking about the Quality in the design, quality in the development, quality in the production is very, very important. So the design for quality is an important aspect. Right from at the design stage, how we are able to bring in the quality into the system, that system need to be established. I think the laboratories have geared up for this, and the systems are designed for quality. Now, after the development phase and producing the systems, ensuring the quality is a very, very important aspect. That's why I use the word sustain the quality. What you have produced, the quality of the first system, and 10,000 system what you produce also should have the same type of a quality, which is important. So, right from the design stage, development stage, and the production stage, the quality needs to be maintained, which calls for many things, whether the capability, the design capability, the review mechanisms what you have, and the documentation what you have, and the skill set what you are developing for the entire workforce, and the continuous training for this workforce is a very important aspect, leaving aside maintaining the infrastructure and equipment and others up to date for the reliability of the production also. Thank you.
Sir, would you like to take some live questions? I hope some of the participants may be permitted to take, if you have time.
I think it is 4-5. We have taken, I think, enough questions. Probably.
Okay. Fair enough, sir. I will just close the session. Thank you very much, sir, for giving such a wonderful topic, and it was very informative. This kind of webinars are going to help the public to understand the importance of DRDO and the contribution of DRDO in terms of defense of our country. At this time, to just set a context, I'm going to share the theme video of the Aero India. Just give me a few minutes. Before that, I will also share with the participants the website which has been discussed with the Secretary, sir. I'm sharing the DRDO website. So I hope you are able to see the DRDO website is live, up and running. All the information which is related to DRDO maybe can be seen here. And any doubts or any queries also can, whatever you posted, which has not been answered now, will be sent to you over the email communication. So I also would like to share the Aero India website at this time. The Aero India website is also up and live. So I request participants to visit this page. I'm sorry, a little bit, I'll just share the Aero India website now. So this is the Aero India website. So all the webinar details are given here. So you can click and join this website. All the information regarding Aero India, the kind of event which is, and the participants, details, and the organizations which are involved. All details are given here, and also the upcoming webinar details also given here. So you can click and join from here also. So we have provided the respective links and the details of the speakers who are going to take the webinars. And the next webinar is also going to be very interesting webinar. So I'm going to share that webinar details right now with you. So the next webinar will be on 23rd January, 3 p.m. Indian Standard Time. And it will be taken by Dr. Kota Harinarayana, INAE Satish Dhawan Chair Professor. He's going to take a session on aviation, artificial intelligence, and agriculture. I hope that will be a very interesting session. I request all the participants who have participated today also to join back for this webinar. So at this moment, I would like to thank a few senior officers who were actually part of this webinar series. I would like to thank Sri M.S. Rao, President and CEO NEGD, for giving us an opportunity to take care of these webinar sessions. And we want to thank Dr. Ajay Kumar, Secretary, Department of Defense Protection, and Sri N.S. Vijendra Sir, Joint Secretary, Department of Defense Protection, along with Captain Roy Joseph, who has been very helpful to coordinate with all the ministry and other stakeholders to conduct this webinar. So we take a sign off at this point of time. I also thank my colleague, Ms. Bhumika, Vimal, Firoz, NEGD Digital India team, for helping me out and assisting to conduct this webinar in a smooth manner. We have actually enabled the polls in order to understand the quality of this webinar. I request all the participants, before signing off, please rate the poll, use the poll tool to give rating to this webinar so that we can improve ourselves in the next webinar. Thank you very much for taking part in this webinar. I thank all the participants and the panelists, especially the senior officers who are actually taking this webinar, taking out time and despite of your busy schedule. Thank you very much, sir, for taking part in this webinar. Thank you very much, and sign off from now and see you on the next webinar. Thank you.